afternoon to all. Today we want to discuss about the 50th unit design of engine components. So we want to know the previous recap of the classes. So we completed the 4th unit design of springs as well as the bearings. So we want to overall recap of the 4th unit. So the recap will be done with the help of our friends Vijay Kishore, Rijwal and Govind. So the three members will take care of the part.
We are going to see about the recaption of the previous class. The recaption which I am going to make is a constant spring balance, constant force spring, which is the constant force spring which we are using in a day-to-day life is a car seatbelt. So the seatbelt which we are using is when we pull the seatbelt, the same force we are using. How the same force is coming? That's the concept which we are using in the constant force. The constant force spring which provides the pulling force, same force throughout the distance that we are carrying to the where we are carrying the distance and the force. To calculate how that is going is we are going to multiply the distance and the force. And also it's majorly used in sequence and tapes and also in some applications where the pulling force is needed. And at the same time that will make some low force. So in the low force itself we can able to pull some objects or something. So the next thing which I am going to say is a constant rolling contact, which gives for a sliding motion. We are taking without sliding motion. We are going for a rolling contact. When the rolling contact is majorly focused on the parts of bearing, which is rotating at two surfaces. In between the ball bearings will be going. In between the ball bearings will be rotating themselves. So hence, why we are using the ball bearings? Is what we are going to say is the ball bearings we are using for low friction, and that will make some bearing low. The bearings of material will be getting low, and then it's used for low friction. It's majorly used in some motors, and where and all the rotating sliding motions in the part of the rotating are used in the rolling friction. Next,
torsion spring. So it's a type of mechanical spring. So it's in a helical shape. So which transfers an torque and load in the helical shape and which converts the load into output. So it's an work-off spring. Okay. So working principle of an torsion spring. So the torsion spring is made up of elastic material or composite material. So like stainless steel or other factors. So which gives an exact load of an shear stress. Which a spring undergoes an shear stress. So the exact load will be conveyed to into out. So it's a concept of the torsion spring. So there is two types in the torsion spring. One is single torsion spring and a double torsion spring. So single torsion spring is a single helical spring will be there. So the energy will be easily, and the energy will be shear stress energy will be easily at N2 out. The single shear spring. So double shear spring, torsion spring, single torsion spring have two types of two springs to be attached at the center section. So the energy will be easily undergoes used in the when it goes up to the heavy weight. It's not other small like hinges and lower hinges. Up to the level it will be used in a single spring, single torsion spring. When to another level above the weight, above the load, it will be used by double spring. So and this have more advantages in the torsion spring. It is some compatibility, which complicated design, which is in a complicated design, the helical shape. So the energy can be easily able to convey. Okay, wow. So hence the spring undergoes a shear stress. The spring has an the spring will be rebounded to the same position by the restoring torque. Okay, wow. So then it has some limitations. The spring only get up to the degree of 360. So that's about the process.
Hello everyone, my name is Dimana Sanu. I'm here to explain on the topic magnetic bearing. So the definition of magnetic bearing is magnetic bearing is a device that supports the rotating shaft by reducing its friction. So example ball bearing. In ball bearing there is contact between the mechanical parts, but in magnetic bearing there is no contact between the mechanical parts. So it is levitated by the magnetic force, magnetic field. Next thing is we are going to see about the working principle of magnetic bearing. The magnetic bearing, working principle of the magnetic bearing, rotating shaft is surrounded by magnets, which creates a magnetic field around the rotating shafts, which makes the magnet, which makes the shafts to levitate and float in the air. If the shaft floats in the air, there is no friction, there is no lubrication needed, there is no wear and tear, and we can move the operation at high speed. Next thing is we are going to see about the types of magnetic bearing. There is two types of magnetic bearing. First one is active magnetic bearing. In active magnetic bearing, we use electromagnets around the shaft. The electromagnets are controlled by the sensors and electronics. And next, it has more precise and easy to control the shafts and movements. Next one is passive magnetic bearing. In passive magnetic bearing, we only use permanent magnets. It is way more simpler and not effective like active magnetic bearing. Next thing is application. In application, we use magnetic bearing in aerospace industry, in jet engines and other examples, other usages. In medical field, we use magnetic bearing in MRI machines and high-speed drills. Next one is the advantages. We come to advantages first. There is no friction used with this. There is no friction between the mechanical parts, and there is no lubrication needed. And we can run the operation with high speed. This is the advantages of this magnetic bearing. Thank you.
Nice presentation for the quiz. So based on this content, we have to solve many problems along with the data. When we come to the theories, so we know the engine components like piston connecting rod. So how we want to design in upcoming classes? With the help of this. Thank you.